In this video, I'm just going to go over a JavaScript program that creates an SVG pentagon and does a little bit more geometry just for fun. Okay, so this is the image that it creates, and it's mostly out of made by JavaScript. Okay, so here is the just in the HTML, the empty container. Well, here's the final. I posted it here. Here is the SVG container at this stage empty. And that is going to, and I have that black border around it, which you saw. So that is the SVG element in the HTML page. And then here's the script that is going to generate it. So I decided I'm going to have a pentagon, 5 vertices, but I did that with a variable n, or not a variable, but constant, I should say. And then I have some center, and I have some distance from the center of my polygon, in this case a pentagon, to the vertices. So I made that 360. So somewhere in here is the center, and the distance in pixels, presumably from the center to these vertices, is 360. I have some initial angle I call theta 0, and here I'm putting it in radians, and it is minus pi on 2. So pi is 180, so pi on 2 is 90, and this is minus 90. So in a coordinate system, the angle 0 in sort of polar coordinates is typically the x-axis, the horizontal, sort of pointing in the positive to the right direction. And sort of in sort of the math and physics classes, you typically go from there, and the angle goes around counterclockwise. But when you're creating images on screens, the angle usually vertical, positive vertical is down, rather than the other things where positive vertical is up. So they typically go around clockwise. Anyway, I wanted one of my vertices, my initial vertex, to be sort of at the top. And so in that coordinate system, that's minus 90. So I wanted one of my vertices to be at the top. And that in the coordinate system that starts at a horizontal and goes around counterclockwise, that's minus 90 degrees, or minus pi on 2. And then I wanted to pick a center, and I picked a center. I made my SVG up here 800 by 800, so I chose a center of 400 and 400. So there we go. I'm going to collect a set of points. So I'm going to have an X, a Y, and I'm going to combine an X and a Y and make it a point. And then I'm going to have a collection of points, and I'm going to call those my vertices. And then I'm going to make that sort of, and then finally then use those variables, arrays, and so on to draw, use SVG to actually draw the image. Okay, so I'm looping over. I'm going from 0 up to 5, not including 5. I am getting an x, which is my center x, plus a radius times the cosine of my initial angle, plus 2 times my counter, times pi, divided by n. So that sort of takes me, divides the 2 pi radians to go all the way around into fifths, and go sort of all the way around, starting at my starting angle, which was minus pi on 2 or minus 90 degrees. So I'm sort of going around in five sort of in 5 steps, going around my circle. I'm getting an X and a Y. I'm pushing the X and pushing the Y onto my point. Then I'm pushing the point onto my array of vertices, and then I'm sort of clearing out the point by setting it back to an empty array there. And then I'm console logging it so then I can see what I have. And then I want to make an SVG polygon out of that to make my pentagon. And so I'm again looping over those. And I'm starting off with an empty string called my points. And then I'm getting each vertex, which is an XY point. So this is sort of, a two-dimensional array or array of arrays. And I'm taking my vertices array at a given, so a component of my vertices array, which is itself an array, and I'm using the join property and joining it with a comma, because the syntax I'm looking for is xy pair separated by a comma, and then those pairs, the components of a pair separated by commas, and then those pairs separated just by a space. So here I'm making a pair separated by a comma, and then here's my additional space over here that's going to be between pairs, and I loop that up. And I had console logged out that, but then I commented that out, so we won't see that in the console log. I'm going up to the page using get element by ID, getting the SVG element, and now I'm using create element to make a polygon. This is, I need to do sort of an expanded namespace, so I can't just use simple create element. I had to use create element NS and say here is where my SVG expanded namespace is. I want from that a polygon. I'm making a polygon, and the polygon is defined by the points with the syntax we discussed above. I have a fill. This is sort of a light yellow. A stroke. This is some dark color going around it, and the stroke width was 5, and then I have to add it. So this is just, doesn't really put it on the page until I do this append to my SVG that what I called my poly. Okay. And so that was this yellow, and it had this sort of, it did have a stroke, so there was a dark border around it. Okay, now I decided to create the edges, and I'm going to do all the possible edges. So I have 5 points, and so I'm going to end up with 5 choose 2, or 10. I'm going to end up with 10 edges. So I'm going to sort of duplicate these outer edges because they are edges, but I'm also going to get these sort of internal edges. I'm going to connect sort of all the possible points with a SVG line. So I have a double loop. I'm looping over I and j, trying to get all the pairs. I starting at 0 and going up to not the last one, which was 4, but even one less than that, 3. And then I'm starting my j at I plus 1 and going up to 4 in this case. All right, so that's my nested loop to get all of my pairs. And then I'm going to define something called an edge, which is going to be an x1, a y1, an x2, and a y2, sort of a beginning point and an ending point. And I guess I figured that was complicated enough that I made it an object. So I had, so I made this thing called an edge. I gave it an x1, y1, x2, y2 based on the ith vertice and the jth vertice. And then when I had an edge, I pushed it on the my edge array. And then I wanted to make a corresponding line. So I'm sort of just doing it in terms of variables, and then I'm putting it on the page in SVG. So I'm making a line, I'm making the x1, y1, x2, y2. These are also the attributes. These are the attributes of a line, and my edge is a line. And I made it a stroke color and a stroke width, and I added my edge to the SVG. And so that's all of these lines. So now that this outer line is sort of drawn twice because my polygon had a stroke, and it is also a line of an edge. Okay. And then I decided, for reasons I'll explain at the end, I also wanted to find out where the edges intersected. And that in particular is these sort of, I'll call them the inner edges. And they can cross at different places. And so I wanted to find out where those spots were. Okay. So I have, with each edge defines a line. I have two sort of line segments. And then the question was, did those line segments, I'm going to go through all of the pairs of line segments, and do they intersect? And so I can write the equation. I can take 2 points, an edge again is 2 points. I can write from those 2 points. I can write the equation for a line. So if I have 2 edges, I can write the equation for 2 lines. And then I can see if the equations for those 2 lines like have a solution, if there's a point where those lines cross. And that's all possible. And then I went and searched for a better method than I was coming up with. And so I just found this thing in Stack Overflow, which I have here. And they consider each, so this was one of my line segments, say, and then this was another line segment. And they write it in terms of, there's a vector P, which is the starting point of one of the segments. And then there is, instead of making their having another vector, which is the second point, they make a vector which is the sort of the change. So R is a sort of a change vector. And so we have P going and P plus R, and that defines this line segment. Sort of P is where it starts, and R is the sort of direction, roughly, in some sense, some kind of slope or something, some change in that P. And they do the same thing for the second line segment, define a starting point and called Q and a change vector S. And then they play this, and then the question is sort of, you can write any point on the line segment as P plus some parameter T times R. So it sort of parameterizes the line. And you can write the other as Q plus US. And then you're asking, does that have a solution? And if you're interested to be sort of on the segments, then you want T to be between 0 and 1 and U to be between 0 and 1. And then they play a game. I won't do it all. I'm just giving you the link, but they play a game with cross products. And anyway, so here it is. So I'm going to make, again, an array of intersections. I'm looping over all my edges, my edge pairs. So I have a nested loop. I'm going all my edges I and all my edges J, and I'm creating some of these cross products. So the X there is just sort of a cross product. And then they define. So P was a point, the first point on the first edge, and R was its change vector, and Q was the first point of the second edge, and S its change vector. And then you're doing the cross product of R and S. So that's what this is. X's and Y's and X's and a difference. Um, and then there was a Q minus P quantity crossed into R, and Q minus P quantity crossed into S. We're going to divide by this R cross X. So we're asking that it's not zero. And then we calculate this the U and the T, those numbers that sort of said where on the line was a point, can be found from this calculation. And then I'm just making sure I don't want to count it as an intersection if it's a vertex. So there will be some solutions where U is zero or U is one, so where I'm at a vertex, at one of the vertices. And I didn't want that. And then I was dealing with floating point numbers, so I didn't want to be, because of some rounding, I didn't want to compare it to make sure it's just greater than zero or less than one. So I went with 0.0, greater than 0.01 and less than 0.99. So the U should be between 0 and 1. The T should be between 0 and 1. And then if it was, then I had an edge. And so then I found this is a point of intersection, which I just called an intersect. And I am using the T1 and finding the point. The T and the U there's a T and a U, and that's where they cross. And this, I'm finding that point using the T and the first segment, I think, which was the P. So then I'm making this list of my edge intersections again. So that's just all, doesn't do anything to the page. It's just the sort of calculation part. And now I am going to make little circles on the points to show on my SVG where that was. Oops, pardon. Where am I at here? So I am creating a circle with that the intersect 0, which was the X, intersect 1, which was the Y. I made a radius of 5. I made it red. And so that's those red dots at my intersect. It turned out there were 5 as I expected. And let me expand this and show the console. And there were my vertices. Here were my 10 edges. And here are my 5 intersects of those. So that's those red dots. That's what I'm calling an intersect. And so then I drew those. Okay. And then why did I want the intersects? Now I finally tell you my motivation of this. I wanted to draw these, the kite and the so-called kite and dart that are part of Penrose Tiling. And so there's a unit called the kite, which is sort of can be thought of as sort of part of this diagram that I've just drawn. So it is sort of 2 vertices and 2 what I called intersects. And then the other unit in this one version of Penrose Tiling called the dart is also sort of 2 vertices and 2 intersections. And I wanted to just draw that because I'm a glutton for punishment. So here is I'm putting together my points, my points list string to make a polygon. And it was vertice 4 and vertice 0, and intersection 1 and intersection 4. And that is making the kite. And then I'm making a polygon with my points. I made it. This is blue with an opacity of a half. And so I can see, because of the opacity, I can see what I had already behind it. And the sort of purpley blue is that kite that I just made. And then finally the kite, or sorry, that was the kite. The dart is vertices 0 and 1, and edge intersections 4 and 1. And I made that one. This is green RGB, so this is a green, and again, an opacity of half. And that was this green dart. And that was all that this was. So just playing around with some geometry, with some SVG, with some JavaScript, having some fun with vectors. That's all. Thanks for your attention.